Hello everyone and welcome back to yet another video. Today we are going to be doing a challenge from Sneak City of 2025, which is called Unfurl, and this challenge is rated as easy. And if you want to follow along with me, you can download the files in the description. I will leave them in my GitHub, and you can just download the files and run the Docker container yourself and do the challenge yourself. So when we get the files, we will have challenge.zip and password.txt. In password.txt there's a password for the challenge.zip file. To unzip it, so I'm just gonna copy the password and then unzip challenge.zip and then paste in the password. Unzip, oh yeah, we will have to paste it without the password, and it will ask us for password later. And now we have all of the files here. First of all, we will have to build a Docker container, so sudo docker build -t, I will call it unfurl, and then dot for the directory, then sudo docker run -it. We will have to forward the port 5000, and then the target is going to be unfurl, like that, and the website is running now. It will take some time for you if you don't have the Docker container pre-built, so you will have to wait a little bit. And when we run the challenge, we will have access to localhost port 5000 here, and we have this open source link unfurler, and it says fetch metadata from an URL. Try it out below. Before jumping into the source code, let's first of all just look through the website of what it does. So if I go to my burp suite, I don't really see anything special with the headers or anything like that. So I will just try to enter in a URL, http example.com, for example, and then I will click on Unfurl. It says example domain, no description found, no image found, and we can see raw HTML here. If I go to the post request, we can see a post request is being made to /unfurl, and we have the source code of example.com here. My first thought that maybe was that maybe we could get like some sort of a XSS, but let's first of all just look at the source code of how this website is built. So the first thing that I thought that we could get an XSS or a SSRF on the server by inputting here, for example, 127.0.0.1 port 5000. Let's click on Unfurl. It says it actually works, so we have a working SSRF here, but let's look at the source code of the challenge. So if I go to the source directory here, we can see all of the JavaScript files and all of the application source code. So I like running Visual Studio Code to just look at the source code with Sneak, so we can get like the vulnerability reports. I will show you it in just a second here. So if I type in code dot, it will open Visual Studio Code in the current working directory. I will just move the Visual Studio Code to my fourth window here, and I will wait for the extensions to load. If you want, you can install this Sneak extension, and if you're pen testing apps, for example, I really recommend this extension because it will just show you vulnerabilities that it will find here, a vulnerable code. Let's see if Sneak finds something useful here. I think I don't really have to connect here because I am already connected, but if you want to install Sneak, you can just go to the extension store, type in Sneak, and then Sneak security here, just download this extension to safely code. And if you're coding or if you're pen testing apps, you will have to install, you can install Sneak, and it will really help you. I see that it is not running for me properly, so I'm just gonna pause the video here and resume when I'm connected. So here we are. I have fixed my Sneak extension here. I have logged in, and we can see that there are a bunch of bugs that it already identified here. So 9 issues found by Sneak already. So let's go take a look at the source code. Sneak will highlight the extension, the problems with the code, the security issues by colors. So orange will be medium severity, red will be high severity probably, and even more redder probably will be the critical severity. So we can see here that there are a couple of red like bugs. So we can see command injection here. This is a very bad bug, obviously. And we have here exec function. So we can take a look at this later function. What do we have here other than command execution? We have SSRF that we have already found on the public routes.js file. So let's just take a look here. We can see access.get our URL, and it's not doing any kind of filtering. We are not filtering for like localhost or something like that. It's just taking a URL and returning you its content from the URL. So the really interesting bug is this command injection, but we can see that it is on the admin routes file. And we can see that there are a couple of users, which some of which are users, and one is administrator user, but we don't really see any like functionality to log into the server. We have /admin, and we can see router.get/, so it is getting / and it is returning admin panel here. But if we go here to / we just get this unfurler. That's because this is another port. There is another port running on the system, and this is the admin panel. And if we would try to go to, for example, /admin, we would cannot get /admin because we are not on that port. So we could probably guess that port, but if we would try to access that port from our website, we would fail because we do not have the permissions to access that host. And we can see that because of the Docker file we have run. So we can see that there is an admin listening. There's the public app running on port 5000 and admin app listening on port 1409. The problem with the challenge was that we didn't know which port was listening as an admin panel. So we will take a look at that later, and we are only exposing the port 5000 here. So if we would even try to access localhost, and then the port was 1409, right? We would get failed to connect to localhost 1409. So with this SSRF that we have found, we can probably try to guess the port for the admin website. So let's assume that we don't really know what the port for the admin website is. So we are just going to enter 127.0.0.1 and then port, we had 5000, right? And it is working for us. So we will have to fuzz here for the port. So what I will do, I will select this port 5000, then type in fuzz here, and then copy the whole request and then put it on a file. So let's go to this section and then let me just create, I will go back from the source code here, and then I will create requests dot unfurl dot request. I'm really terrible with names, and then I will put the request here, and I will run ff to fuzz for the port. So let me run the ff command. So ff-h to get the help page for ff, and to put in the request we have -request and -request proto. So ff-request unfurl.request, I name it, then -request-proto http, then the word list will be /user share seclists discovery. No, we are not gonna use the seclist word list because we only need numbers. So I'm just gonna generate my own word list. So sec from 0 to 5, like 65355, like that. I think that's the port, that's the max port 65355. Max port, I don't really remember. 65535, right? Almost correct. So 65535, and then we have the word list for all the ports, and I'm just gonna put them to ports.txt. We have all the ports here, so let me just run the ff command now. So ff-request unfurl-request, then -request-proto will be http, then the file -word list will be ./port.txt, and we can see that it is running and it has already found port 1409. That's going to be our admin interface. So if I paste it here, we can see from the response that it says admin panel, and we have all of the content that we can access as admin. Great, so now we have found an admin panel. But now let's take a look at how the code execution works and how can we get the code execution working to run commands on the target computer. So let me go to admin routes and just find the code execution here. So it is this exec and it is command injection. And actually I'm just gonna hide these yellow lines because it is hard to read. So let's go to the sneak extension. Then scroll down to sneak severity, and I see that I have already all of those off. Let's see. It's finding more issues because I have these off. I'm not really sure how can I disable this. So I'm just gonna open the source code in Vim so it is easier to read. So cd route, I think, and or admin.js. What was the file? On 4, I think it's admin routes.js. Yeah, admin routes.js. So and then admin routes.js, and let's scroll down to find that exec function. It's going to be under /execute, so we can access the /execute. So, and we can see that there are a couple of comments. This isn't terribly secure, but we are only going to bind this app to the local host, so you'd need to be on the actual host to run any commands. So I think we are good. And it is getting the client IP address, and then it is checking if the client IP address is 127.0.0.1 or IPv6, and if it's not any of these, it's going to send us unauthorized access attempt from client IP. And probably if you would try to access /execute, it will fail because we do not have the client IP address of 127.0.0.1. If it passes this function, we can then send the command parameter, and it says no command parameter provided if it's not there, and if it is provided, we are going to just execute the command here. Let's see, how do I not see where it is executing the command? It's executing this somewhere. Let's see, there's this exec. Did I delete it? Oh yeah, exec. I'm just terribly blind, I'm sorry. So there's this exec, and it is executing the command that we have provided. So if it fails, it says command execution failed and error. So now let's think, how can we bypass this check for localhost? Because if we would try any other path for admin, so for example /settings, it is not checking for like the localhost. So settings here, it works because it is not doing any checks of our like localhost. Logs will work as well, users will work as well. So if we would read all of the source code, we would not find anything that we can take advantage of. I was thinking that we maybe can access like from this URL, maybe that unfurl with the parameter to maybe like do this SSRF again. But I don't think it is possible unless we can send the unfurl as a get parameter. Let's actually try that. So So change request method, we will get /unfurl, and then the parameter URL is going to be the URL. Let's see if this will work. So question mark URL is equal to HTTP 127.127.0.0.1 port 5000, and it says cannot get /unfurl, so it is only accepting the GET request. If we would take a look at the source code, we would probably see that as well. Let's see, is it asking for POST request? Where is it? Submit and method POST. So yeah, it is only accepting the POST request, and it is not looking for the GET request. So we cannot do that. It is out of possibility. The next thing that we could try is by injecting a header that is not like forbidden by the website. So there are a couple of headers that we could try to inject that would change our IP address that we are requesting from. So if I would go to MDN documentation for X headers, maybe something like that, X forwarded for HTTP headers. Let's see, can we find something here? We can find all of the headers in the MDN documentation, and MDN is just web documents for basically everything, every header, everything that you might need while doing requests. There's also, if you are into like documentation, there's also RFC that you should read, because RFC is just the standards for all of the packets and everything. So these are the main two websites that I go to if I need to read like actual documentation, and we can scroll down and find some of the headers that might help us. So let's actually try to find something that will help us. And I know that there are a couple of those X like forwarded headers, so let's try to find those. I will just search for X forwarded, and we can see non-standard headers here. So X forwarded for identifies the originating IP address of a client connecting to a web server through an HTTP proxy or a load balancer. We also have forwarded host, identifies the original host requested that a client used to connect. So we can try some of those headers. So let's first of all try X forwarded for and try to access that website with this header. So because it is checking that our client IP should be 127.0.0.1 or this IPv6 loopback address, we can just X forward dash 4 and then 127.0.0.1. Let's see, we can still access the main website. Now let's try to execute, and it is probably going to fail because we have this condition for if the CMD is not present. So let's try to provide that CMD equals ls. Let's see. And it actually worked because we have this X forwarded for header. If I would delete this header, I wasn't expecting that to work, but yeah, so this HTTP header is not actually needed for this challenge because we are already accessing the website from our local IP address. That's actually really interesting. I didn't expect this to work. I'm just gonna add it anyways to the request, but we can see that there's command output, and then we can see the output from the ls. No title found. Let's see, what if I ID command? Yeah, we can see that there is the ID command here. So if we wanted to get the flag, we will type in cat %20. So it's URL encoded space. If we would go to decoder and type in space and then encode as URL, we could see this is %20. And then cat, I accidentally ran this command, flag.txt, is it here? Yep, and we have the flag for the challenge, which it says flag not really though. So this is going to be it for this challenge. I hope you enjoyed the video. Please make sure to subscribe and like the video. If you have any questions, leave them down in the comments, and I will see you in the next one. Goodbye.